Hello everyone. So this is a question from NEET 2026. Identify the incorrect statement from the following. And there are a few statements given to us. The chapters involved is P block 11th and P block 12th. Okay. So statement A is carbon has the ability to form P pi multiple bond with itself. Okay. P pi multiple bond with itself. Okay. So P pi multiple bond is a chemical bond where a pi bond is formed by side or lateral overlap. So pi bond is formed by lateral overlap of two p orbitals from two atoms. Okay, that is with respect to diagram. So this is the p orbital which is contributed by an atom. This is the p orbital which is contributed by another atom, and this overlap is the p pi bond. Okay, so it is known as a p pi multiple bond because, as we know, a pi bond is always accompanied by a sigma bond. So therefore p pi bonds can be seen in either a double bond or in a triple bond. So that's why p pi multiple bond. Now, due to small size and high electronegativity, small size and high electronegativity, both of these factors leads to appreciable overlap. Carbon has strong tendency to form p pi multiple bonds with itself. Carbon has strong tendency to form p pi multiple bonds with itself. Okay. For example, C double bond C in C2H4 ethene. Okay. One of the bond is pi, the other bond is sigma. With respect to diagram, ethene looks something like this. Okay. So this is the sp2 hybrid orbital, this is the sp2 hybrid orbital, this is also sp2, sp2, sp2 and sp2. And this are the two unhybridized 2p orbitals which overlap laterally, which can be shown like this. And this is the p pi bond which is present in C double bond C. Okay, we can also find p pi bond in C triple bond C, where the two bonds are pi bonds, which are p pi bonds, which is present in C2H2 ethyne. Okay, so one extra point is that as we move down the group from carbon to lead, ability to form p pi multiple bonds decreases. And this decrease is due to corresponding increase in size, which leads to bigger orbitals, and decrease in electronegativity of atoms. Okay, so the decrease is because of increase in size, and which leads to bigger orbitals, and also decrease in electronegativity down the group as we come from carbon to lead. Okay, and bigger orbitals overlap less effectively because their electron density is spread out over a larger volume. For example, so you can see in bigger orbitals, electron density is spread out over a larger volume, which prevents the electron from concentrating in the tiny overlapping region between the two atomic nuclei, and hence they overlap less effectively. Now, therefore, statement A is a correct statement. So it says that carbon has the ability to form p pi multiple bond with itself is correct. Okay. Now coming to statement B, which says that ECl3, where E can be either boron or aluminium, is a monomer when E is boron and is a dimer when E is aluminium. Okay, so monomer is a single fundamental molecular unit. Dimer is a larger molecule, obviously, which is formed by linking exactly two monomers together. Formed by linking two monomers together. Okay, in both BCl3 and AlCl3, number of electrons around the central atom is only 6. Okay, with respect to diagram, you can see boron has 2, 3, 4, 5, 6 electrons around it. Aluminium also has 2, 3, 4, 5, 6 electrons around it. So therefore they behave as electron deficient molecules. So these guys are electron deficient molecules. They are also known as Lewis acids. Okay, obviously because their octet is not complete. Okay, but only aluminium halides, for example this guy, exist as dimer. That is with respect to diagram. So giving the small aluminium as blue color and the bigger chlorine as green color. Okay, so the point is that only aluminum halides, for example AlCl3, exist as dimers, but boron halides, for example BCl3, exist only as monomers. Okay, very important. So this guy exists as a monomer and this guy exists as a dimer, as you can see. Okay, the reason is boron atom is so small that its radius is 85 picometer and the radius of aluminium is 143 picometer. So you can see the difference. Okay, so the reason is boron atom is so small that it cannot accommodate 4 large sized halogen atoms around it like aluminium does. Aluminium can surround itself by 4 chlorine atoms, but boron, because of its very small size, cannot do it. Okay, if it does, if boron does, it will result into huge interatomic repulsions because it's a smaller sized atom. 4 chlorines will be surrounding it, so it will lead to huge repulsions. So therefore, statement B, which says that BCl3 is a monomer and AlCl3 is a dimer, is a correct statement. Coming to statement C, which says that, or which talks about the order of catenation property of group 14 elements, and catenation is ability of similar atoms to link with one another through covalent bonds. Important. Ability of similar atoms to link with one another through covalent bonds. Carbon shows the maximum ability of catenation due to small size. Carbon maximum catenation. So the reason first is small size, belongs to the second period. Then it has very high electronegativity compared to the other members. And the third reason is high strength of CC bonds. And this is, to be specific, 348 kilojoules per mole. That means this much amount of energy is required to break such CC bonds. Okay, so therefore, because of these three reasons, it forms long, straight, or branched carbon-carbon chains or rings of different size and shape. And as we move from carbon to lead down the group, the element-element bond energy decreases. Element-element bond energy decreases. For example, in CC, we know it is 348 kilojoules per mole. In silicon, the bond energy is 297 kilojoules per mole. Germanium is 260 kilojoules per mole. Tin bonds are having 240 kilojoules per mole, and Pb or lead bonds are 81 kilojoules per mole. So you can see the bonds that carbon forms with itself are the strongest, and hence it forms very stable compounds, and therefore it shows extensive catenation, ability of catenation. Okay, so therefore catenation, because of these values, decreases in the order carbon, which is very high, compared to silicon, which is higher than germanium, which has approximately similar ability compared to tin, which has very high ability compared to lead. So therefore statement C is correct. Statement D says that oxygen exhibits only -2 oxidation state, which is incorrect, because in case of superoxides, for example KO2, its oxidation state is -1/2, and in the case of peroxides, for example H2O2 hydrogen peroxide, it's -1. So therefore the incorrect statement is D. Okay, so therefore the final answer is D. Okay, thank you.